The power needed by a bird during flapping mode is P equals, the power equals to alpha V to the 3 plus beta times mg over x to the 2 all over V, which in this formula alpha and beta are just constant. Those are just constant numbers. V is the velocity, m is the mass of the bird, x is the fraction of flying time spent in flapping mode, so x is the time. Find these partial derivative of power with respect to velocity, partial derivative of p, power with respect to x, which is time, and partial derivative of power with respect to mass, and interpret all of them. First, we want to find the partial derivative of p with respect to v. In both of the terms, we have velocity. So, before we start, I prefer to rewrite my function in the form of p equals alpha v to the 3 plus beta times mg over x to the 2. If you want, you can raise each term to the 2, m2 g2 over x2 times by v to the negative 1. The reason I'm bringing v to the numerator is that I want to take the derivative of this with respect to v, and I don't like to use quotient rule for finding derivative with respect to v. Let us start. What is the derivative? Derivative would be 3 alpha v2, derivative of the first term. For the second term, this is constant because we take derivative with respect to v. For that, we bring the power down to here, and then we subtract the power by 1. So from the power rule, derivative would be negative beta times mg over x all to the 2v to the negative 2. This is our answer for the derivative. And if you want, you can bring back down v to the negative 2 to the denominator and write it as v to the 2 in the denominator. It's up to you. But what is interpretation? Whenever we take any derivative or any partial derivative, one interpretation is rate of change. Rate of change of what? Rate of change of the function with respect to the variable. So interpretation for this is the rate of change. Always it's a rate of change. Rate of change of what? Rate of change of the power of the bird needed during flapping mode. I don't want to write all of that. So rate of change of the power of the bird needed during the flapping mode with respect to what? With respect to the variable that is in the bottom. With respect to the velocity, with respect to the velocity. This is interpretation for this partial derivative. And of course, this interpretation is valid when the mass remains constant. When x remains the constant, the other variables remain constant. So finally, let's summarize what is the interpretation. Interpretation is this. This derivative shows rate of change of power with respect to velocity. Because power is in the top, always the derivative shows rate of change of the function with respect to the variable. Function is the one that is in the top, variable is the one that is in the denominator. So this is interpretation for this. Let's find the other partial derivative. So now we want to find the partial derivative of p with respect to x. For finding the partial derivative of p with respect to x, I rewrite my function in the form of p alpha v to the 3 plus beta m2 g2 x to the negative 2 v to the negative 1. Now the partial derivative of p with respect to x would be, derivative of this term would be 0 because we don't have any x in that term, so 0 plus derivative of beta m2 g2 x to the negative 2 v to the negative 1 is negative 2. We bring the power down, negative 2 beta m2 g2 x to the negative 3 v to the negative 1. And if you don't like this format of the answer, you can rewrite in the fraction form. You can bring the terms with negative power down to the denominator and write with positive powers. But it's okay to leave it in that form. What is interpretation for this? This interpretation shows rate of change of power, because power is in the top. So rate of change of power with respect to x. What is x in the question? Attention, x is the fraction of time. So this shows rate of change of power with respect to fraction of time spent in flapping mode when other variables, which are velocity and mass, are constant. This is interpretation for this. Finally, we want to find the partial derivative of p with respect to m. From this partial derivative of p with respect to variable m, yes, this is the last variable, would be derivative of the first term, because we don't have any m in the first term, it's 0, plus beta is the constant, so we keep the beta. Derivative of m to the 2 would be 2m, so 2m g2 x to the negative 2 v to the negative 1. Can you interpret this? I give you some time, you can interpret by yourself, then I tell you what is the interpretation for this. So this shows rate of change of power with respect to the mass of the bird when velocity and fraction of time during flapping mode is constant. So briefly, what is interpretation? Rate of change of power with respect to mass. I hope you like this video. If you like this video, please subscribe in my channel. It helps the channel to grow and more people can use this channel. Thank you for watching.